Hi, I'm Dimitri. I'm from Ocean Protocol. Today we'll be kicking off the first session of Nature 2.0. We call it Plugged In. And for this, we brought a dog and a robot and a few knives, and we're going to see who's going to win. I'm going to lure the dog in. No. No, it's not about putting humans or animals against machines. It's about having them co-create something. For this, we have a three-tier approach. One of them is plug your systems into something that's decentralized, autonomous. The second part is have those agents that you now put in there, make them self-owned, maybe self-controlled, make them run on the substrate. And then in the last moment, in the third session, we're going to try to add some intelligence layer on top of it and maybe tie it into legal systems and things like that. So really trying to create an alternative universe that hooks into the physical world. For this, I had to look into a few inspirational things. One of them was a talk about desertification. That's when the edge of the desert becomes larger and larger, and it basically threatens the zone around it. There's a lot of projects trying to avoid this desertification, but it's a huge problem because you have migrations of animals and people, and you basically have less sustainable land. And there's a big growth rate of this, and there's a person called Alan Savory, and he tried a few approaches. In his first try, he was thinking that, well, it's about, he's from South Africa. And in his first try, he was thinking, well, maybe it's the big animals here. And they had a lot of, it was back in the 80s, they had a lot of elephants. And he said, well, we have to reduce the amount of elephants in order for them not to trample the land. So we killed about 40,000 elephants under approval of the local government and all of that, and nothing happened. So that was just a loss. And he started, well, he was devastated, of course, but he didn't give up and started realizing that in order to make land more fertile, you not only have to invent something that's close to agriculture, but close to natural biological systems, which means that you not only want to have animals that fertilize a place, but you also want to move them along a trail like predators would do. So for this, he designed a recipe that basically, what they call, you could call it planned grazing. So basically you take your cattle, you move it along a grid, but you make sure it doesn't stay at the same place. And this has been implemented in many different types of areas of the world, global areas, and has proven a lot of results. And it's a specific recipe that can tackle this type of behavior. Another thing that's really interesting, and that's a talk you should definitely see, it's about Willy Smits, which is a Dutch guy. And he has a passion for chimpanzees and orangutans, and he went to Borneo because there he saw that there was a huge depletion of these monkeys in the rainforest there. And he noticed that a lot of things happened because poor local economy, a lot of forest fires, just people trying to survive, people having to do this, take these actions like get rid of the rainforest, take those resources, sell them. But then he managed to do this. He turned, in 8 years, a fully blank, chopped down rainforest into a regenerated primary rainforest. And for this he had a different plan, a different recipe. And this recipe was very interesting because it has a layered approach and it's very ecosystem integral. So he started off with getting rid of the forest fires, putting acacia trees as basically fire-resistant borders, and then starting with agriculture. And each layer of the agriculture adds a new layer of soil, a new level of trees and plants. And he did this in multiple phases, but made sure that the local communities always could extract the resources, maintain it such that they went on the market, had economical value, but also didn't want to do it too fast, so they didn't have to immigrate new people, but really could sustain the local economy. So you have this full circle recipe that makes these things possible. So that got me thinking, well, basically, there's a lot of things happening in the world, and there's a lot of resource depletion, a lot of natural disasters, but they all have different types of local needs. So can we design recipes that can tackle local areas that are integrated with local communities, etc.? And well, since we're from a tech space, we thought, well, how can technology help here? How can we make these recipes be more committal, more community-driven, decentralized, make them into real organizations? Does the recipe need a human, or can it do without a human? So then we went back to maybe a blog post on the Ethereum blog from Stefan Tual, and he was talking about deodants. And deodants it comes from a novel from Carl Schroeder, who's also working now together with Stefan Tual. He's basically a sci-fi author, but he talks about resources that have the same capabilities as humans have. This means that they have a form of intelligence, they can transact on resources, they have legal status, they basically have a sort of personhood or humanhood. So a forest that you would call yourself would be a deodant, but any natural resource. And you can also apply this to infrastructure, like, say, grids, roads, any type of basic human needs, albeit mobility, transport, energy, food, shelter. So these are things that people really need, and it starts to form a form of commons between us. It's something that we all need, and we need to respect the resources that we have for it. So an interesting approach we can take is look at, well, if you go from something that's passive to something that's active and self-actualized, there is this Maslow's pyramid, which talks about what are the basic needs that you have to implement in an agent or a system in order to become more and more human. So I try to apply this, and this is kind of the road we're trying to follow with this Nature 2 track. And at the bottom, we have the basic needs: food, resources, warmth. And that means that we have to create something that has sensors. It has eyes, it has ears, but it also has actuators. It can manipulate the resources around it. If we go a level above, you're talking about safety. So safety in a human sense is having the ability to become a legal actor and to make sure that you're protected by a government or a law that's implemented by the government. And then you can go steps above, for example, like empathy, having friends and family, having the ability to have self-esteem, to perform well, to have maybe social responsibilities, and then in the end, a form of intelligence and creativity. So I don't think we'll get here by February, but there is interesting things you can explore on each of these levels. So, and I'm just going to try to give you a bit of a feeling of what we can do right now. So the driving forces, and this is more of the background of my daily job, is about we create decentralized systems. We do it for AI and data at Ocean Protocol. And self-sovereignty is a big part of decentralization because people have control of their own keys, the keys to their own data. With Bitcoin, you have control over your own coins without having to go to a bank. If there is a bank run, then first one wins, last one loses. With Bitcoin, it's more, or any type of other token economy, you always have access to your coins, whether they're valueless or valueful, but you always have access, and you decide what to do with it. Something that's really interesting in this decentralized space is that you can implement incentives in this network. You can reward good behavior, or you can punish bad behavior. You can basically create and assign tokens, you can mint them, and give them to people that you think behave correctly. And there you can implement network objective functions. See how does this system want to evolve. And lastly, we use a lot of cryptography to prove things that happen in the real world. For example, with Bitcoin mining, you would prove that you actually did computation because you have to compute a difficult cryptographic puzzle. You can only do that with so much probability if you spend enough resources. So these can be altogether become really interesting building blocks or paradigm shifts to implement systems that we're talking about. And the system that we're talking about is typically, well, it's a deodorant, but if we can implement it as a decentralized autonomous organization. What is this? Well, it's basically, if we look at decentralized systems, these are systems that are unstoppable until the last nodes in the system survive. So these, as long as people are running computers and connect to that system, the software on that system won't die out. It will always commit to that software. So interestingly, if you deploy some code on that network, I'm pretty sure it's going to get executed on that network. Whether you leave, whether you walk away, whether some nodes fail, it will execute. So having that decentralized infrastructure allows us to create something like, you could say, viruses. Viruses that may be spread and are available, but they don't have to be bad viruses. They can also be good viruses. This is just an analogy. So one of the things that I'm thinking of is, what if we have these recipes that basically manage and control natural resources, have them run unstoppable on these substrates, such that if they are incentivizing people like, hey, take care of me, then those people will know they will get paid if there is funds attached to it. So there's a few steps towards this. First of all, we have to connect the physical to the digital. Interlink is working on digital twins. Xane and Weave are working on decentralized access policies and privacy-preserving computation, and it all fits in having secure hardware connected to the real world. This means that if something happens in the real world, you can prove that it actually happened. You can make sure that it happens in the right way and that it gets connected to this unstoppable substrate. Now, you can think of a lot of drones, and I think we have one little robot running around that we can basically add a decentralized access policy to. So this means that the person controlling the drone is assigned by the network. So what does this mean? This means that, well, if you want to define what your natural resource is, then your eyes, your sensors, your ears can be robots. They can basically be sensors, secure hardware, connecting to a smart contract. And if there is that smart contract, if it has some funds in them, it can pay through streaming payments towards those sensors or those robots. So there is like an economy between the ledger, the funds on that ledger, and all the peripheral hardware that gets hired basically by the natural resource. If you look at nature to human interactions, it becomes a bit more interesting because it becomes a bit more fuzzy and subjective. I actually found somewhere a project that tries to actually communicate with a plant. Well, it just measures how dry the plant is, and the plant then reports that it's not feeling well and you have to do something. But what's more interesting is that if you look at this decentralized substrate, connecting to it is similar. It's an agent. It's an agent to the system. Whether that agent is the actual natural resource governed by a decentralized autonomous organization, or whether it's a bot with a wallet, or whether it's a human with a wallet, they all have wallets. To the system, it doesn't really matter. So now they can start transacting with each other. And this is a very interesting thing because I don't think it really happened much before, where in history of mankind, where robots actually could own their own funds without the human having to own the funds of the robot. So these agents can go gradually without custodian. So that's a form of self-ownedness in the system. If they then can make decisions by themselves, they can interact with multiple agents according to their likings and their behavior. So I put a bit of pseudocode next to the slides. It would be cool to see these things implemented where two agents interact and exchange resources. Or they maybe play a game. And that's a very interesting thing because people like to play games. And maybe that's a way how we can fuel these initial recipes, these initial decentralized autonomous organizations. Just gamify it. If you look at a human, then the brain consists of two parts. Consists of a rational decision maker and something that just want to play around, an instant gratification monkey. And they have two different types of objectives. This one is just thinking about eating the plate and grab whatever he sees. The other one is thinking about the future, about sustainability, long-term objectives. And then you can connect. People are receptive to these networks that have incentives built in, because they have the ability to create an advantage for themselves, to get more resources, and they would behave themselves according to that network objective. Think about Facebook, give away your data and connect with your friends. Or think about Bitcoin, get money rewards, so buy hardware. So people are actually doing stuff because this digital system gives them an incentive to do so. Of course, if you mal-design, if you wrongly design your system and your objective, then you end up creating something that is sometimes a metaphor to a paperclip optimizer. A paperclip optimizer only has one objective function: create new paperclips. So imagine this paperclip would be a smart system. Then the first thing it would do, it would try to communicate with humans in order to get more compute resources, to become smarter, to outsmart the humans. If it can outsmart the humans, it can take more resources from the humans, so they can create more paperclips until all metal in the earth is gone, and then it has to migrate to another place. But that's basically what's happening with the Bitcoin system and other type of networks. So carefully designing this network objective function, which has to be this fully socially, economically integrated system, is one of the more interesting things that we can do right now. This doesn't mean that you have to be able to code it. At least you have to be able to find what should look like in order to create a harmonious system between all agents. So there's a lot of reward functions you can think of, and with some of them, most of them are zero-sum games. This means that I have A resources, you have B resources. In the end, we're still going to have to get A plus B resources. No new resources created. But there are a few interesting systems or games to play, and maybe we could play one here. Let me see. Without me. So this one is called the dollar auction. So it's very simple, and we can play it together. I have, let's say, 20 euros. And we're going to have bits from €1 each. Yeah, so you start with 1 and then €2. And the highest bid has to pay his bid, but it gets the 20 euros. But importantly, the second bidder also has to pay. Right? So I'm putting this for auction. Who's paying €1? Okay. €2? €3? €3 there. €4? €4 there. So €3 still pays. €4 you're winning. €5? €5? €6? We have 6 and 5. 7? 8? 15? So I'm already winning. Huh? We have 15 plus 8. I'm at 23. I'm winning already. Unfortunately, you guys can't stop overbidding each other. You will go above 20 in order to cut your losses. And the interesting part about this game, it becomes, if you're with 2 people in the room, you can coordinate. You can get my money. But the more people in the room, the less coordination you have, and only one person has to put out a second bid you guys are in the loss. You will always try to over. So the more people, the less coordination, the less winnings for you, the more winnings for me. But these are interesting games. People like to play them without thinking about the consequences. If we look at what's happening on the crypto side of things, there we have these, basically, you can set up any type of game or lottery or any type of incentive mechanism, and I listed a few here that I find interesting to explore. One of them are called automated market makers. Think of this as being a resource exchanger, a token for token or tit for tat, and that's always available. It will always, if you want to buy and sell, there's always a robot willing to sell and buy. You can have, interestingly, a very cool bonding curve in there. And a bonding curve is basically setting the price of your token exchange according to a predefined function. So if you say, well, first people that are buying in paying less than the last people, then you have an early mover advantage. You can play with that curve, you can ripple it, you can have different input curves and output curves, extract rent from it, give dividends from it, just by defining a very simple mathematical function and put it to an automated exchange. Secondly, we have coordination games, where we're looking at something called shelling points. The shelling point is where people would automatically converge to. For example, they asked 1,000 New Yorkers, imagine you have a date with somebody, but you forgot time and place, where would you go? And most people would have these, would say, well, 12 at the Grand Station or something, or maybe another famous icon, but they would always, like, that would be a focal point, a shelling point. This is something you find in communities a lot. And a lot of people here are working on something called token-created registries. These are whitelists or blacklists of items that people agree upon in a community that they should be on the whitelist or on the blacklist. I think Weave can tell us more about those things. And then digital scarcity. Digital is there to be replicated, to be viral, to be copied. We started 5 years ago with a company called Ascribe in order to make digital scarcity a reality for protecting, for example, creators that create digital movies or songs or images. And then they can create unique editions out of this. This kind of evolved over time into something that people now call non-fungible tokens. These are tokens that aren't really like currency, they're more like patents, they're more like IP. And then auctions, we just played an interesting auction called the dollar auctions, there's a few others. And then one of my favorites is called radical markets. Radical markets, they're close to liquid democracy, where you basically can delegate your voice or your vote. But by doing so, the power of your vote, if you give it away, if you delegate it, the power goes quadratically down, or according to the square root. And then there is something very interesting, it's called Harburger taxes. And Harburger taxes is a new form, it's not new, but now we can actually build it. It's a form of pricing assets. Imagine you have real estate. And your real estate, you have to pay 10% taxes on that annually. Now, you have to pay 10% taxes on what you value your own real estate. You can set your price, and if you set your price, you're committed to sell at that price. So typically people would put that price out there, but you have to pay taxes on that. So you say, maybe I shouldn't put it that high because I have to pay taxes. So I can choose my own equilibrium point. I think we have these two forces, the taxes pulling my price point down, and then my personal gains pulling it up, and it will create an equilibrium without the market. Normally pricing goes with bid and ask in the market, and you have a spread, but this doesn't require another actor besides myself. So very interesting stuff. There's a lot of cool, smart contracts you can look at. I put two of them here that don't exist yet, and I love to see them. One of them I call the Banksy contract. You buy something, but you don't know if it's going to destroy itself once you buy it. And then the black hole contract, you put money in there, you don't know where the money is going, you don't know what's going to return. Just weird. People might find that interesting. If we then go one step up, so machines can talk to nature, nature can talk to humans, humans can talk to machines, we can exchange resources, we can play games with each other. And now we're going to look at what's legal, what's not. Can we defend ourselves? Well, there are a few really interesting projects. One of them is in New Zealand. I don't know if you know, but in New Zealand, rivers have legal status. A river can actually sue in court a human or a corporation. And this is because there's two types of people in New Zealand. You have the Maori, the local tribes, who regard natural resources as humans, as being the same level of humans. And then we have people that just say, well, we just have law. And they had to come together in some point, and that's where they decided to inherit this Maori feeling of natural resources and to put it on the same level as legals. So this is going to be very interesting to see, can we implement this in other places? Can we tie legal status to natural resources? Well, in Dubai, I think it's Dubai, I might, well, somewhere around there, Saudi Arabia, oh yeah, and that's the weird part of it, because yeah, they're not so pro-woman in legal. Yeah, so Sophia got legal status right there. And now there is, in Malta, there is a lot of regulations trying to see, can we create these decentralized autonomous organizations? Can we give them legal status? And here's then the trick. You create a DAO, and gradually you move out the humans and create self-owned, self-conscious agents attached to it that make the decision-making about the funds of the DAO. Now you have controlled funds without human guardian on top of it. So I think maybe in a not so far future we can create interesting systems out of these things. And if we do so, we have to think about what's empathy. I sometimes try to encode empathy in something that I would say it's a knowledge graph. How many minutes? I have 5 more minutes. Plus questions? Okay. Well. Oh. No. I'll just go a bit quicker. So with empathic protocols, I mean that you can estimate what are the wants and the needs of another agent in the system. What if we have our knowledge graphs that says, well, these are the resources that I'm going to need on a daily basis or a monthly basis, and I need this. Well, if you can expose that knowledge graph, albeit through any type of data structure, and then you can normalize it such that I can to how my knowledge graph looks like, and then I can understand how you think. Or at least how it doesn't, on a human level it's going to be tough, but on an agent level it's going to be not so hard to do. So you can basically, you can also inject parts of your knowledge graph in other people's knowledge graphs or other agents' knowledge graphs, which automatically translates into the concepts that they have in their knowledge graph. So this could be a way of agents communicating with each other and respecting the space of their resources. So putting it a bit on a timeline, going from corporations into cooperatives sometimes, not always. We had the DAO, which can burn some money, but sometimes it's really useful. We're exploring these non-human agents that can own resources, but not somebody owning that resource. We can create wallets that nobody can touch, but they basically the private key is hidden within the hardware. And then we can create AI DAOs. DAOs that are fueled by artificial intelligence. There is not more human decision-making, but machine decision-making in there. So these are really self-owned, self-decisive machines running on this unstoppable substrate. There's one that we are collaborating with, it's called Autonomous. Autonomous, and it has a GitHub repo, it's working. It's basically an AI artist. It creates arts, and it puts that art into an auction. And when it sells the art, it gets the money from the humans. And it decides whether it needs more compute to create new art or just piles up the money somewhere. And with money we mean tokens. These things aren't too hard to build. There are templates out there how to do this. And then we can create self-driving cars, autonomous machines, self-owning machines. Maybe we can look at mobility in a whole new way. Maybe the car pays the road road extracts harbor taxes, self-owning wind farms, what have you. But the cool thing is that in these systems, they're all agents. Nobody knows you're a horse, you're a tree, you're a bot. They're all agents, and they have actions between agents. So for Ocean Protocol, we say, well, in Ocean Protocol, nobody knows you're a data set. Nobody knows you're a machine learning algorithm. You're just an actor in the system. So that's it. I think we have time for questions left, or not. Otherwise, we can just have a beer afterwards. There is. Oh, this is so weird.
All right, my question is, you mentioned actually your Ocean Protocol. What's the technical difference between, for example, Ethereum protocol? Or could you explain with a few words, 2 words, 3 words? Do you using different cryptographic method, different elliptic curve, or what's the essential technical difference?
So, if you're looking at the system that we're building, a layer 2 solution, and we say Ethereum is a layer 1 solution. It's a bare-bone substrate to do decentralized virtual machine, decentralized compute. What we do is we build decentralized data pipelines on top of that. We tap into those processors that are decentralizedly running. We have our native token, but with a different application area. We confine ourselves to giving access to data sets, machine algorithms, having validation on top of that. We're basically on top of a layer 1 solution like Ethereum, but could also be EOS, could also be something else. We just need to have a virtual machine underneath us. It's a protocol. We're using the technology of fat protocols, where you have multiple protocols on top of each other. Think about how the internet stack looks like. You have this OSI stack. At the bottom you have hardware, then you have the IP language, then you have sessions, you have applications. But each of them have their own protocol, and you abstract yourself such that you don't need to know the details about the underlying protocol.
Could you explain how those self-owned agents can solve the environmental problems in the first slides that you mentioned?
Yeah, so it has to start with humans. So I think, I would say, let's think about those recipes, where a local community expresses their wants and needs and saying, we have a problem. And then they would basically create something like a corporation or something like a cooperative, and need funds. So it's all about governing those funds. And now we have 2 options. We can either have a human decide on where the funds go, or we can have a full feedback mechanism, a machine that's basically dispensing rewards according to KPI. You trust the mathematics and the rules.
Okay, so quick question. Oh. The mathematics and the rules, when applied to engineering, they follow a linear logic. Nature has another logic. How are we going to deal with this?
So I don't think that's true. I would take a systems theory approach here, where you basically try to model a system, you measure a system, and have a control loop around that.
But for measuring a system, you have to define it and to set. Yep. Nature has no bound.
No, but those local areas have.
And it's hard to define them, to encapsulate them.
But that doesn't stop people of doing stuff.
And they are damaging them because of that. Because the whole.
Exactly. So if we have better and larger feedback systems, where not everything is looked at as an externality, then, but then what you're proposing is a collaborative tissue, a unique source of truth that goes around the globe. So that's kind of what that substrate means.
Yeah, but exactly this, and this doesn't follow a linear logic of construction. For example, one of the problems here is the very act of defining the problem.
That's a start, but it's also about governing the objective function. You don't want to make it sensitive to initial conditions. You want to have long-term and short-term feedback cycles. You want to have data capturing in the middle. You really have to look at this as a cyber-physical system who have been designed in the past, but not at a scale that we can do right now. So and that's a very good point, and you need people that think more broadly than just looking at the specific subdomain problem. But yeah. Hello? Hello? I would say in order for these things to become widely deployed and a commodity, then they have to be large scale developed. That's one thing. What we're looking at is an experimental sandbox, a place to explore and play with these new types of market mechanisms, with these new types of human-machine, human nature. So we're building basically a toolkit. We're not deploying an entire worldwide thing. We're building a toolkit that not only consists of technology, but also thinks about ethics, about feedback systems, philosophy, all these things behind it. Start somewhere. So I'm thinking that one of the most interesting places to start with is something more experimental, something more in the art sphere, something where you create a narrative rather than a solution. Because you need a lot of people, you need to commoditize all this knowledge and hardware and software and what have you in order to deploy this at a large scale. So what we're proposing here is, of course, an experimental sandbox for people to play with and implement with.
So from what I understand, Ocean is kind of a decentralized marketplace for data. How does all of this, I guess, Nature 2.0 stuff that you're working on fit in with the broader vision of Ocean?
Well, with Ocean, we have a few objectives, and one of the main objectives is incentivizing the commons. And the commons, instead of open free data and knowledge and machine learning and artificial intelligence, break open silos and have them not the personal private data, but the thing that should be shared with the world, made that commonized. So that's where we basically have a clear interface. And also if these systems, if you want to play with this Nature 2.0, there's going to be a lot of data capturing, there's going to be a lot of machine learning attached to it to make that decision making on point. We design incentives to make stuff for free or to fund projects that don't have capitalistic interest. So that's a few of those building blocks that we're also employing at the Ocean Protocol side.
Cool, makes sense.
Okay, I think we have time for this question if someone wants to ask.
Yeah, in the one of your last slides, you put this meme about the Skynet with this decentralized artificial intelligence, autonomous organizations. Like, where would you put the limit of the objective of these DAOs? No, like for example, building, or for example, these autonomous. No, like. Where is the limit where this artificial intelligence would say, I won't manipulate the price, or I would use it in the right way, or where's that boundary? Like?
That's a very, very difficult question to answer. I mean, you always want to have like at least a pause button or maybe a stop and kill button as a human, protecting your resources and your species. Maybe the nature is thinking, where is the limit of the humans from that side? I think looking at stability in systems, that's something you can measure, where it's say that the amount of resources flowing in equals the amount of resources going out. This system is self-sustaining because it's self-dependent. So that would be interesting points to follow. Of course, things can go malicious, but then they need to have a form of governance. They need to have feedback systems, complex task, but interesting to think about.